Hey, Jeaner. I'm gonna just go in order of the questions that you sent me. I think you sent me six of them, so I'm just gonna start with the lowest number one. So I'm starting off with question three, which says that we have a solution of acetic acid, which is 50% CH3COOH by mass and has a density of 1.15 grams per milliliter. Calculate the molarity of the solution. So let's break this down in parts. The first part is saying that we have a solution of acetic acid that is 50% CH3COOH by mass. Okay, so what does that mean? That means that we have 50% of CH3COOH by mass. So the way that I would break this down, you could break it down into multiple ways. You could say, well, 50% is 1 out of 2, 50% is 25 out of 50, but I'm going to just say, for simplicity's sake, that it is 50 out of 100. And this trick is going to work for any fraction that you choose, but 50 out of 100 is just easy to do. So 50, I'm going to say that if you're 50% by mass, that means 50 grams of whatever you're talking about. In this case, it's CH3COOH, makes up 100 grams if the total is 100 grams. And so the total is referred to in chemistry as just the solution. So basically, I'm saying that if we have like a beaker and it's full of a whole bunch of stuff, 50% of it is, or if the whole thing is 100 grams, half of it is this CH3COOH, and this 100 grams could just be called the solution because it's a mix of 50 grams of CH3COOH and 50 grams of who knows what. But the whole point is that we know that we have CH3COOH and we have a solution made up of everything in this beaker. Okay, so that's just kind of explaining probably what you already know about solution being the whole thing, and that the CH3COOH they're just saying is half of that solution. Okay, so the next part of the question is saying that we have a density of 1.15 grams per milliliters. So we have 1.15 grams per milliliter. And so this is our density. And so one important thing to keep in mind about density is that it's always going to be grams of solution over milliliters of solution, because in this case they're talking about the density of the solution. So both the top and the bottom are solution. Okay, so the last part of the question is telling us to calculate the molarity of the solution. So now they're talking about the molarity. We know that the molarity is always our moles of solute. Here, let me write molarity first. Molarity is equal to moles of solute over liters of solution. Okay, so this is always, so you always have to memorize not only the units like grams, milliliters, moles, and liters, but you should be memorizing as well this part right here, that density is solution on both top and bottom, and molarity is solute on the top and solution on the bottom. Okay, so now that we know all the background information, we could solve the problem. So what I'm basically going to be doing is just be doing a huge train track to try and get from our starting point, which is going to be our density, and getting to our ending point, which is our molarity, which is what they're asking for. So let's start down here. So we know that we initially have 1.15 grams per milliliter of solution. Solution down here. And the first step that I'm going to try and do is get from our milliliters of solution, which we have right now, and our final answer, which is this molarity, is having a unit of liters of solution. So that's pretty easy, right? Because we're in solution for both of these. So I could just say that I know that 1,000 milliliters of solution makes up 1 liter of solution. So this and this cancels out. And so right now I'm satisfied in this bottom part right here, right? So I'm going to leave that part alone, but now I got to convert this part right here. Okay, so I need to get from grams of solution to moles of solute. So one thing that I could do to get from grams of solution to moles of solute is to use what they gave us up here, right? That it's 50% acetic acid per solution. And so what I could use then is that ratio that I used up there, that I have 50 grams of CH3COOH per 100 grams of solution. And like I said, you don't have to use this ratio as long as you use one of the ratios that say that we have 50% of CH3COOH. And so grams of solution and grams of solution cancel out. And I think one big thing that you have to know is that right here, our CH3COOH is our solute. So CH3COOH is our solute. And what does that mean? We're in the units of grams per solute. And what we need is moles per solute. So we're almost there. Okay, so the last thing we have to do is go from grams of solute to moles of solute. The only way to go from grams to moles is by using your molar mass, right? This part you should be an expert at. So you know that acetic acid, if you break it down, you know the C is 12, the H is 1, the O's are 16. And so you add all those together and you know that CH3COOH is 60.05 grams per mole. And so what do we finally have? We finally have our moles of solute, just like right here, and our liters of solution, just like right here. So if we calculate this whole train track out, what we'll have is 9.575 moles of solute per liters of solution, which is basically saying that our molarity is equal to 9.575, which is answer B.